This is Module 5, Lesson 17, Problem Set. Number 1 says locate and label the following fractions on the number line. They've already created a number line for us from 0 to 3, and then they've given us fractions that all have 6s as their denominators. So since we know we're working with sixths, we're going to break up each whole into 6 parts. And we know that 0 is 0 sixths. And that happens to be our first fraction, so we're already done with that one. Anytime the denominator and the numerator match, that means it's 1. So our second fraction in the list that we're supposed to put on the number line is 6 sixths, and therefore we know that it's 1 whole. And if 6 sixths is 1 whole, 6 times 2 is 12, so we know that 12 sixths is 2 wholes. 3 sixths, we have to start over at 0 and count to the right 3 dash marks to get 3 sixths. So we have 1, 2, 3. I'm going to put our 3 sixths down here since it's a little too close to the slash I made up above. And then 9 sixths, we could start at the 6 sixths marking and start counting from there. So then we start with 6, 7, 8, 9 sixths is right there. And then like we did on lesson 17, we'll put a box around each of the whole numbers. So then on number 2, it also says to locate and label the following fractions on the number line. This time we're starting with 1 at the far left of our number line and ending with 4. We also see that our denominators are 4, and so therefore we have to break up each whole into fourths. And knowing from number 1 that our numerator and denominator, when they are the same, they create 1 whole, we know that 1 at the very beginning of our number line is 4 fourths. So that'll be our starting point. So then 8 fourths is 4 times 2, or 4 plus 4, which is 2 wholes. So 8 fourths is 2 wholes. For 6 fourths, we can start at the 4 fourths and count over 2 more spots, and we get 6 fourths right there. 12 fourths, we can think 4 times what equals 12? Oh, it's 3. So we know that 3 wholes is 12 fourths. If you weren't sure, then you could always start at the 4 and continue counting over, and then you'll end up at the 3 wholes. So then 16 fourths is our last fraction. You could either count from the 12 and go 13, 14, 15, 16, or you can say 4 times 4 is 16, so we know that 16 fourths is 4 wholes. And then like we did on number 1, we'll box the whole numbers. So then on number 3, locate and label the following fractions on the number line. This time they started the number line with 2 and ended with 6, and we're working with thirds because all the denominators have a 3. All right, so 18 thirds. Well, let's start with our whole number 2. If we're talking thirds, 3 over 3 is 1 whole. So 3 times 2 is 6. So 6/3 is 2 wholes. So now we can go continue on. The next one, if you wanted to, since all the denominators are 3, you could just put the numerators in number order. So 6 being the smallest number, 9 would be the next closest number. So starting at the 6 and going over to the right, 7, 8, 9. 9/3 is 3 wholes. The next numerator in order would be 11. So 11/3, we can continue from the 9, 10, 11, and mark that. The next numerator in order would be 14. So 14 going from 11, 12, 13, 14. 14/3 is just before you get to the 5 wholes. And then 18/3. If you right away know that 6 times 3 is 18, you might know, oh, I know that that is 6 wholes. But if you don't know, you can go from the 14 and count. 15, 16, 17, 18. 18/3 is 6 wholes. And then box our whole numbers. Okay, moving on. Number 4. For a measurement project in math class, students measured the lengths of their pinky fingers. Alex's measured 2 inches long. Jeremiah's pinky finger was 7/4 inches long. Whose finger is longer? Draw a number line to help prove your answer. So we'll draw our number line. Starting with 0. And the longest, well, we don't know what the longest is, but as of right now, let's just end it at 2. If we need to make it a little bit longer, we can. We know we're working with fourths because Jeremiah's pinky finger was 7/4. So we'll break these into fourths. And I'm going to just draw little mini pictures. So Alex and Jeremiah. Alex's finger. Nail on there. Some knuckles. Oh, it is not as easy to draw. Scratch the drawings. We will just label. Alex, 2 inches. Jeremiah, 7/4 inches. So now let's put those on our number line. 2 inches, if we're talking fourths, is 4 times 2, which is 8/4. Jeremiah's was 7/4, so his is slightly shorter than Alex's. 7/4 is shorter than 2. Oh, I should put 7/4 inches is shorter than 2 inches, or 8/4 inches. So then number 5, Marcy ran 4 kilometers after school. She stopped to tie her shoelace at 7/5 kilometers. Then she stopped to switch songs on her iPod at 12/5 kilometers. Draw a number line showing Marcy's run. Include her starting and finish points and the 2 places where she stopped. All right, so we'll create our number line. says she ran 4 kilometers, so that's going to be our ending point. And we are working with fifths, so we have to break up each whole into 5 parts. Now this is the starting point, and this is the finish. So we have kilometers, don't forget to label. And we have to mark where 7/5 is. Well, 0/5 is obviously at 0. So we can start counting from there, or we can remember our 5/5 is 1 whole, and then count 2 more from there, which gives us 7/5. This is where she tied her shoelace. Then at 12/5, if we know that 5/5 is 1, 5 times 2 is 10, so our 2 wholes is 10/5. And then we can continue to move over 2 spaces for the 12/5. And this is where she switched songs. If you want to make it very clear which spots each of your changes happen, you can put dots on your number line. You don't have to put dots on your whole numbers because nothing happened at those. Those were just reference points. So that's the end of Module 5, Lesson 17, Problem Set.